So covalent bonds come in two kinds, polar covalent or nonpolar covalent. Now, watch the animation to refresh yourself on the difference between the two. Covalent bonds are created by sharing a pair of electrons between two atoms. Covalent bonds usually form between two nonmetals, and they're generally considered weaker than ionic bonds, but look at the energy range. Depending on which atoms are sharing the electrons, you get between 150 and 1100 kilojoules of energy released. So some covalent bonds are actually more stable than some of the weaker ionic bonds. A single atom can form multiple covalent bonds depending on how many valence electrons are available. So that's how we get double bonds and triple bonds being made. Covalent bonds are formed by overlapping two partially filled orbitals. And what that does is it forms a new orbital that has less energy. And this is how it does it. If we take a look at this diagram here, if I have two hydrogen atoms, for example, each would have an electron in the 1s orbital. In order for those two hydrogens to share electrons, I have to bring the atoms close enough so that the 1s orbitals overlap each other. Now mathematically this is what happens. Each 1s orbital has a 95% chance of finding the electron there. Where they overlap, I get a region where I'm going to find electrons more than 95% of the time. So whenever a covalent bond forms, you've got an orbital where you really have a good chance of finding electrons. Now, when you bring two atoms close to each other, something special really happens. It's known as optimum particle separation. What you get is you get a balance between the attractive and the repulsive forces between the two nuclei and the two electrons. So the two atoms, there's a minimum distance that they want to be apart from each other. Because the nuclei are both positive, they'll repel each other. And because the electrons from each atom are both negative, they'll repel each other as well. But remember, there's always an attractive force between opposite charges. So there's an attractive force at an angle here and at an angle here, all the way around forming a box. And when a covalent bond forms, the net force acting on that system of particles is actually zero. The repulsion and the attraction balance each other out. So this is known as optimum particle separation. So how does this release energy? Well, in order to have optimal particle separation, the electrons need to stay put. That means that they have to slow down. They can't wave back and forth as much as they used to when the atom was independent. That means that the electron loses kinetic energy. And that energy gets released into the environment. Now you can look up how much energy different elements give off when they form covalent bonds. It's called a bond energy table. Now, how do you tell what kind of bond forms between two elements, whether it's going to be nonpolar or polar, or even ionic? In grade 11, we showed you that you can use the difference in electronegativity values between two elements in order to figure out what kind of bond will form. So here's the scale we gave you. Now, if you have an electronegativity difference between 0 and 0.5, it means that you have relatively equal sharing of electrons between the two atoms, and there's basically no charge difference. So you have a nonpolar covalent bond. If it's between 0.5 and 1.7, means you have unequal sharing of electrons. One atom is pulling on that pair of electrons harder, which would create a partial negative charge on that atom and a partial positive charge on the other. This is known as having a polar covalent bond. And anything higher than 1.7, which means you have such a strong attraction, you'll get an electron transfer, creating a cation and an anion, so you get an ionic bond. Now, try this out. What type of bond would you get between each of these sets of elements? Now, use your periodic table in the back of the textbook to find electronegativity numbers.